Okay, another video. This should be Scientific Notation Part 1 in your note packet. And now we're taking these powers of 10 and writing these really big or really small numbers in what we call scientific notation. All right, if you look at your note packet, right at the very top, there is a box that explains what a number has to be like, or what it has to look like to be in scientific notation. All right, and there are a couple of major things that you want to look for. First of all, this number right here, that first number that comes along, must be greater than 1 and less than 10. All right, so if you look at this number 1.908, that is definitely greater than 1 and less than 10. So far so good. You always have a multiplication symbol right here, and you have a 10 with some kind of exponent up here. So it looks like this one. The first one, you can put a yes. All right, this is in scientific notation. Alrighty, now if I want to convert that number to a regular number, here's all I do. I look at this exponent, and since it is positive, that means I'm going to take this decimal and I'm going to move it that many places to the right. All right? So if I was going to convert that number to regular standard notation, the decimal started here, I would count 1, 2, 3, and I've got to go 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 places. Okay? So I've got to fill in all of those zeros to take those place values. All right? So it doesn't just take that many zeros. You've got to look at where the decimal started. And if the decimal started here, then yes, 17 zeros. But the decimal started here. So 1, 2, 3 moves were to get to the end. So I have 14 more zeros. Okay? And I can write in some commas. That doesn't really look the greatest because it's still in red, but I can separate them with commas if I want to. So that number is this number in scientific notation. All right, or this is the standard and this is the scientific notation. All right. Okay, let's take a look at the second one here. Is this in scientific notation? And I'm going to say no. And here's reasoning. Because I look at this number and it has to be greater than 1, less than 10. Well, 0.325 is not greater than 1. So immediately we just say no for that one. We look at this next one down, 7.99 times 10 to the 32nd. That number is in between or greater than 1, less than 10. I've got the multiplication sign here, and I've got a 10 raised to a power, so yes, that is in scientific notation. Now again, I want you to get in the practice of converting it to a standard number. So, how many zeros, let's not write the whole thing out, but how many zeros would I have if I were to convert that to a standard number? All right, so you can see where the decimal starts. I would take 1, 2 moves to get to the other side of that 9. That means I would have 30 more places to go. So I would have 7, 9, 9, and then 30 zeros. I'm not going to write them all out, but I'd have 30 more zeros at the end there. Okay? Take a look at the next one here. Here's why we're going to say no for this one. You have a plus sign there. Okay? So you never, ever have a plus sign there. If it were a multiplication symbol, we'd say yes. Okay, next one down. This one, we're going to look at this number, and we're going to say no again. Okay, because we have to have a number greater than 1 and less than 10, and that definitely is. Now, there is not. We could convert this to a number that is in scientific notation by simply doing this. We want to move this decimal place 1 over, and that would make that number greater than 1, less than 10. So when I do that, I could do that. Okay, all that stays the same. This is times 10. All that does is change this one greater. Okay, I moved it one place to the left, and that changes that to one greater. Okay, and here's another mistake that we have. So it really is not as easy as this, but this is a 5 and not a 10. Okay, so we're going to have to stick with no. If it was a 10, I could turn it into this very easily, and then that'd be in scientific notation. Okay, but we're going to have to stick with no on that one. All right, and this one, let's see, this 8, definitely less than 10 and greater than 1. So that's good. We've got multiplication. We've got a 10. We've got a power. Yes, that one is all good. So very quickly, how to write a number in scientific notation. We kind of did it through going through these examples. Now we're going to actually use them a little bit on the next few. Okay, so let's try the next couple examples here and actually use these numbers, these rather large numbers. And the first one, actually this is exercise 7, says convert California's debt into scientific notation. All right, so nothing new. It's just like what we did before. We want to take this number now and convert it into scientific notation. Now, one thing you got to know is the decimal place is at the end. If there's no decimal place there or decimal there, the decimal sits at the end. So I need to start moving this decimal over until I get a number that is less than 10 and it is greater than 1. So it looks like I have to go, oh, there's 40.7. I have to go all the way to there. All right? So what I did is I moved that decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. All right? So 4.07, because that's where I moved the decimal place to. And all I have to do is go out until I run out of decimals, or run out of digits, I should say. All right? So 4.07 times 10, that never changes if I'm putting it in scientific notation. I got to make a better 10 there. All right? And 4.07 times 10, how many places did I move that? I moved it 11 places, so there you go. All right, that's in scientific notation. All right. The next one down, they wanted me to do the same thing. So again, I don't see a decimal here, so here's the decimal. I have to move it 1, 2, 3, 4, and that makes the number 6.9 times 10 to the 1, 2, 3, 4. I moved it 4 places. All right, so that is this number in scientific notation. All right, and the last two, now we want to actually do something with these numbers. Okay, this is a little more complicated once you start adding and subtracting them and such. They want to know what is the difference between California's population and North Dakota's population. All right, so the word difference is a little vocabulary for you. The word difference means to subtract. So we are going to subtract these two. Now I know we could take our calculator, punch it in, or just write it down on a piece of paper, but the idea is we want to practice subtracting numbers that are in scientific notation. So let's convert this one. All right, this would convert to 3.8 times 10 to the, how many places do I have to move it? I have to move it 1, 2, 3, 4, 5, 6, 7. So this is 3.8 times 10 to the 7th. And this number is, we already did this one up here, it's 6.9 times 10 to the 4th. Now, here's the thing. When we want to subtract numbers in scientific notation, you cannot do it unless these two exponents are the same. All right, so we want to change one of these numbers so that the exponents are the same. Okay, and I'm going to change the bigger number. All right, I'm going to make this the same exponent as that one. All right, so I need to change this 7. I want to turn this into a 4, all right? And here's how I do it. I'm going to go down here and do it down here. All right, so 3.8 times 10 to the 7th. Okay, every time I move this decimal, to the right one place, it changes this number to be one smaller. All right. So I need to move that decimal so that this turns into a 4. So I need to move it 3 places. Okay. Well, what would that do? That'd take 3.8. 1, 2, 3. 3,800. Okay. So 3,800 times 10 to the 4th. Okay, so if you didn't catch how I did that, go back and rewind and watch this again. You've got to get these numbers to be the same. All right, so now we just subtract them. 3,800 minus 6.9. So if we want to, we can bring up our calculator and we can go 3,800 minus 6.9, and I get 3793.1. So 3793.1 times 10 to the 4th. Okay, here's a neat thing. When I subtract them, I do not have to subtract these 10 to the 4th over here. That stays the same. All right. Now, in order to be in good scientific notation, it needs to be this decimal over here. But we just want to know the difference, so let's take it out of scientific notation. All right, this 4 means move that decimal 4 places to the right. So I'm going to add 3 zeros. 1, 2, 3, 4. Okay, so there is my difference in population for those two. Again, that's a big step. All right, that is a big step to what we did up here. All right, so if you need to, you rewind it and watch this example again. All right, but the big thing is you've got to make these the same, and you do that by moving this decimal how many places you need to. Okay? All right, so one more example to go here. What they want us to do now in number 10 here is sum. Now, when I see the word sum, that means add everything together. So I'm going to convert these into scientific notation. I'm going to do it a little quicker since we've done a bunch of these already. So this is going to be 3.37 times 10 to the, let's see, 3, 6, 9, 10, 11. All right, I'm going to put this one into scientific notation. That's going to be 4.0 times 10 to the 10th. Okay, and this one's going to be 2.0 times 10 to the 10th. All right, so I'm going to add these all up, but the same thing. I've got to get these to be the same if I can add them. All right, so if I move this decimal to the right, it's going to make this number smaller. All right, so that's what I'm going to do. I'm going to give myself a little space down here. I'm going to make this 33.7 times 10 to the 10th. I'm going to leave the other ones all by themselves. Not by themselves, but I'm going to leave them alone. All right, so those are all 10 to the 10th. Now, since those are the same, I can add these all up. All right, so if I add these numbers, I get 39.7. And just like when we subtract them, that stays the same. That is a 10. All right, maybe I can make that a little better and make that into a 10. Okay, I'll get my pen back, make that into a 10. All right, so that's in scientific notation. If you want to convert it back to a regular number, how many zeros would I add here? Well, I've got to move that decimal 1 to get around there, and then I'd have 9 left. So I'd have 397. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I add New York's, Vermont's, and Wyoming's debt altogether, oh, that's a pretty big number, $397 trillion. Okay, so again, those last couple, that was a big jump. All right, making those decimals the same, or not decimals, the exponents the same. I just cannot make a dollar sign today. All right, so make sure you understand how I did that, how I converted that into that. Okay, and again, if you need to, you go back and watch it again.